Hello, my dear students. Welcome you all to Shri Jain Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the general organic chemistry. As we have started GOC in the last two turns, when this is the fourth lecture of GOC, we were discussing the IUPAC nomenclature. Today we are going to discuss about the naming of compounds having more than one functional group attached to it, that is polyfunctional compounds. As you know, in polyfunctional compounds, if there are two groups present in which one group is more reactive than the other, then the naming will be done accordingly. I'm giving you some examples. For example, if the compound is this, so this is carbon and other two chlorine atoms. So COCl, this is the group which is known as what? Acid chloride. The suffix for acid chloride is alkanoyl chloride, that is methanol chloride, and this carbon is also attached to a chloro in a halo group. So the name comes to be chloromethanol chloride. There will be no capital. It will be written as chloromethanol chloride, right? Then IPAC name for urea. This group is acidamide, a derivative of carboxylic acid, named as carboxymide, that is methonamide. Sorry, attached to the amino group, name comes to be aminomethanamide. A carbon chain attached to aldehydic group as well as a ketonic group. Aldehyde group is more reactive than ketone. We will use prefix for keto. This is CHO. And this is C double bond. This carbon is also attached with one hydrogen. This is CHO group. So 1, 2, 3, 4, 5. So it is pentanal, okay, attached with a ketonic group on third position. So 3-oxo-pentanal. Then, if a group containing alcohol, carboxylic acid, and a keto group or an aldehydic group, this is carboxylic acid group. This is OH, and this is a keto group. So OH and keto, they will come in the prefix. So H for hydroxy, mean the prefix of OH is hydroxy. Alphabetically H will come first and oxo will come afterwards. So it becomes 1, 2, 3, 4, 5. So it is pentanoic acid basically. Second is hydroxy. and third is oxo, right? So 2 hydroxy 3-oxo-pentanoic acid. This is C double bond O, a keto group. But this C double bond is not alone, it is CONH2, that is, it is amide. So it is amino group attached as a substituent. Okay, this is the first carbon and second carbon. Second carbon is having amino, so 2-amino ethonamide. Okay, now the second rule for writing the polyfunctional compounds is when principal group is selected, then there is no use of priority table. Like this is the compound. So there are two carboxylic acid group attached to it. So it is dioic acid. So 1, 2, 3, 4. Right? If we do numbering like this, 1, 2, 3, 4, the name come will 3 amino, 3 hydroxy, sorry, 2 hydroxy, butane, 1,4 dioic acid. But this is incorrect. This is incorrect. Because in amino and hydroxy, amino group will come first. So the numbering will be like this: 1, 2, 3, and 4. So it will come 2 amino, 3 hydroxy, butane, 1,4 dioic acid. Okay, this is correct. Rule third: if any Dawn functional groups are those groups which are having carbon and their carbon is counted as the part of the parent hydrocarbon chain, and we will count or we will start the numbering from that carbon. If any Dawn functional group is present as secondary functional group, then its E is not included in principal carbon chain, except CHO group. Like for example, Sorry, sorry. It is not C, it is carbon. Then its carbon is not included in the principal chain except CHO group. Like for here, we will not count this carbon. We will take the carbon here. Okay. So one, two, three. It is propanoic acid. And third position is having cyano. 3-cyanopropanoic acid. So here we will take a prefix for this, that is halocarbonyl. So we are having one, two, three. Third position is having this compound used as a prefix 3-chlorocarbonyl propanoic acid. Okay. So we are here we are having C double bond to NH2, and here we are having C double bond to Cl. Okay. So C double bond to NH2 amide is less reactive than C double bond to Cl. This is more reactive. Then it comes the prefix for acid amide is carbamoyl. This carbamoyl methanoyl chloride. Okay. This is acetamide, which is the principal group attached with the alkyne. Alkyne will be taken as a prefix. And on the third carbon, we are having a ethyl group as well. Okay. So it will come one, two, three. This is the side chain. Okay. So 3-ethyl pent 4-ine 1-amide. Okay. In this, we will use carboxylic acid. We will also take into consideration the carbon of this CHO, as it is an exception to the above rule. So we will use a prefix oxo or formyl, 4-oxobutanoic acid. Okay. In the second position, 1, 2. Second position is we are formyl. So 2-formyl. The longest carbon chain 1, 2, 3, 4. Butane 1,4 diamide. Okay. Other than CHO group, all the functional groups which are having carbon, if they are attached with the principal group, like carboxylic acid is attached, and the other group like carboxylic anhydride or any carboxylic derivative is attached, mm, the carbon will not be counted. Okay. Other than the carboxylic acid, okay, or the parent hydrocarbon chain, except CHO is an example. Okay. Cyclohexane carboxylic acid. Okay. This is the rule number fifth, that if CHO group is not counted as a principal, mean it if its carbon cannot be counted as a principal functional group, okay, then when it is a principal functional group, but this carbon is not attached to the carbon chain directly, okay, this is a cyclic chain and it is not attached to it, okay, the carbon is not attached to the cyclic carbon chain, then it will be written as carboxylic acid. If it is here, then we will write benzene carboxylic acid. Propane 1, 2, 3 tricarbandehyde. Okay, these rules are for polyfunctional compounds. Okay, you cannot take the carbon chain like this 1, 2, 3, 4, 5. You will miss this group. Okay, so in writing this, you have to do what? You have to take this carbon as a parent hydrocarbon chain. Okay, same for carboxylic acid. Propane 1, 2, 3 tricarboxylic acid. So the rule is basically, if any non-functional group is present as principal functional group in main functional group and its carbon is not attached to the parent hydrocarbon chain, okay, then we use the above examples. Now in this case, for the first time you will use the prefix for this group, that is COH. Okay, so it comes to be 3, because 1, 2, 3, 4, 5. Okay, 3 carboxymethyl. This is the prefix for COH is carboxy, and for this the prefix is methyl. It becomes carboxymethyl. 3 carboxymethyl pentane 1,5 dioic acid. Because here this COH group it cannot be a part of the principal hydrocarbon chain. You cannot go clockwise or anti-clockwise. You have to go in a one direction, in one direction. You cannot reverse. Okay, that is why. Now, one question for you. Please solve this compound and tell me the answer. The naming of this group. Okay. Now, now we are going to discuss nomenclature of alicyclic compounds. Okay. For unsubstituted alicyclic compound, when there is no substitution, only chain is there, you have you have to use u prefix, then root word, word root, then suffix. Okay, like prefix will always cyclo. The word root basically contains number of carbon, and the suffix is either ane or ene. Like this, cyclopropane, like this, cyclobutane. Okay, cyclohexene. Okay, in case of substituted cyclic compounds, whether that substitution is closed or open chain, saturated. For example, the substitution, it can be also closed like the cyclic compound, or it can be open chain, okay, or saturated, means having carbon carbon single bond. Now in this case, the first rule is if the number of carbon in closed chain is greater than or equal to number of carbon in open saturated chain, then closed chain will be selected as the parent chain. Will be selected as parent chain. Okay, like for example, this is the side chain, this is the 1, 2 or 3. On first carbon you are having a side chain. The number of side chains of the substituent are lesser in comparison to the closed chain. Okay, 1 methyl cyclopropane. Now the 3 carbon side chain is attached to the closed chain, so it will be taken as a side chain. Okay, so you will start numbering from here: 1, 2, 3, 4, 5. Okay, it will become propyl cyclopentane. Okay. If the number of carbon in open chain is more than closed chain, then open chain will be the parent chain. Like okay, 1, 2, 3, 4, 5, and this is a 4 carbon atoms. Okay, so this is one cyclobutyl pentane. Okay, closed chain is having more number of carbon atoms. So it is 1 ethyl, 2 methyl, cyclobutane. Okay, cyclic compounds with functional group are parent chain, cyclopropane carboxylic acid. Cyclohexane 1,2 dicarboxylic acid. As this carbon is not the part of the parent chain, this carbon will not be, the carbon of this group, down group, is not counted as a parent chain carbon. That is why it is written as carboxylic acid. Okay. If the functional group is attached to the side chain, attached to the side chain, the functional group is attached to the side chain is further attached to the closed chain. Okay, then it will be written as, then this is the main group. Please remember, then this is the main group. Okay, then this cyclohexyl, which is the substituent ethanoic acid. Okay, if the functional group is present on both cyclic and open chain, cyclic and non-cyclic substituent, the number of carbon atoms is considered. Like CH2COH. Here you can see COH is attached to the cyclic chain, and here COH is attached to a side chain which is further attached to this cyclic chain. The numbering will be started from here, 1, 2, 3, 4, 5, 6. So it becomes cyclohexane carboxylic acid. and the prefix is used for this. This is carboxymethanol. Okay, 3-carboxymethanol, methyl cyclohexane carboxylic acid. Okay, if two cycle means substituent is also a cyclic chain. Okay, the one which is having lesser number of carbon atoms will be counted as a side chain. Cyclopentyl, cyclohexane. In case of unsaturation, either the open chain or the closed chain which is having the double bond or the triple bond means the multiple bond 1 2 3. Okay, then it is 3 butyl cyclopropene. We will not consider the carbon atom in this case. 2, this is 1 cyclopentyl ethene. Okay, then select it as parent chain. If the ring and the non-cyclic part both are having double bond, both are unsaturated, then calculate the number of carbon atoms. Okay, so here number of carbon atoms you can see that 1 2 3 3 carbon, and here 5 carbons. Okay, this will be the parent chain. 1 2 3, sorry, I think I have, yeah, by mistake. So it is having 5 carbon, it is having 3 carbon. So the one which is having 1 2, because this side chain will be nearest to this position, 1 2 3 4 5, so it becomes cyclopentene, and this is having 3 1 2 3. This will be a complex side chain. It will be written in parentheses. On the third carbon, the side chain is attached to the main carbon chain. So 3 prop 2 in yl, yl. 3 prop 2 enal cyclopent 1e. Okay, or cyclopentene. Understood? 1 2 3 4. Two double bonds are there. Okay. So if a open chain or a closed chain one is having more number of double bond will be selected. Will act as parent chain. 1, 2, 3, 4, 5. Okay, so it will be selected as the parent chain. So it is butane 1, 4 diene, and on the first position we are having a cyclopent 1 cyclopentenyl and 2 enyl butane 1, 4 diene. Okay. In case of ester, if you are having the alkyl groups both which are the side chains. Okay. One thing please remember, in case of multiple double bond, use A instead of E. Okay, so it will become buta 1, 4 di. Understood? Now here in this case, what will be the naming? The parent hydrocarbon chain means the carbon C double bond O, and this group, it will be the parent chain. The group which is attached directly to C double bond O, and the group which is attached to oxygen will be the alkyl. So this is cyclobutyl cyclohexane carboxylate. Okay, so these are some examples. Okay, so my dear students, I will be starting the naming of bicyclo and spiro compounds in the next lecture. Till then, bye bye, take care, stay safe, stay healthy.